Hey everyone, so today we're going to be talking about finding the number of divisors. Before we get started, we must first identify what is a divisor. A divisor is also known as a factor, and it's a number that can evenly divide into another number. So we're going to take a look at 2, 3, 4, 5, 6, 8, 9, and 10 because those are the most crucial divisibility rules that you need to know. And I'm pretty sure everyone knows the divisibility rule for number 2. That is if the number ends in an even number. So if it ends in 0, 2, 4, 6, or 8, then the whole number is divisible by 2. For 3, if all the digits add up to be a multiple of 3, that is when the entire number is a multiple of 3. So for instance, 123, the digits add up to be 6, and 6 is a multiple of 3, therefore the whole number is a multiple of 3. For 4, if the last two digits combine to be a multiple of 4. So notice the difference in the verbs. So this here says add and this says combine. And the way I define this is, say you have 128. So it says the last two digits. So we're going to look at 28, and 28 together is divisible by 4. So the whole number 1028 is going to be divisible by 4. Now, the divisibility rule for 5 is the last digit is either 0 or 5. So 15, 30, 105, so on and so forth. For 6, the divisibility rule states that it must be divisible by both 2 and 3. So you can just test the number for these two conditions, and then you'll know that the number is divisible by 6. So for 8, the last three digits combine to be a multiple of 8. So notice that 4 and 8 are very similar in that they both require the last so many digits to be a multiple of the number. So in this case, we would have something like maybe 10408, and that is the 408 is going to be divisible by 8. Now, you'll notice that even so, 408, you still have to kind of divide to figure out whether or not it's divisible by 8, but it's a lot easier to divide 3 digits instead of 5 digits or 7 digits or however many digits they want to give you. So 9 is similar, again, just like 4 and 8 are similar, 3 and 9 are actually very similar, except the only difference is that the digits must add to be multiple of 9. So in this case, it would be something along the lines of 135. That adds up to be 9. So since 9 is obviously divisible by 9, 135 is going to be divisible by 9. And for the last one, 10, the last digit must also be 0. So those are it for the divisibility rules. So now we can move on to finding the number of divisors. So first we're going to start off with a warm-up problem. So we're going to take a look and figure out the number of divisors of 1,000. So 1,000, I'm pretty sure we can actually sit down and figure out the number of divisors for 1,000. So we're going to go ahead and do that. Now, there's two ways to do this. One, we can either go in order and list them until we reach the square root. Because that's when the numbers will start to repeat, or not repeat necessarily, but that's when they'll start to create pairs. Or 2, we can, every number is divisible by 1. So we know 1,000 is divisible by 1. And then we have 2. We know it's not 3 because these don't add up to be a multiple of 3. 4, the last two digits, 0, is divisible by 4. 5 is divisible because it ends in a 0. 6 is not because it's not divisible by both 2 and 3. 7, we don't have a rule for it that is very easy to memorize. There is a rule, but it's not worth memorizing unless you really want to. But 7, when we go and take a look at it, 7 does not work. 8 does work because the last three digits are a multiple of 8. 9 does not work. Another trick is if 3 does not work, the 9 won't work. 10 does work. Okay, so now it gets a little bit tricky. So now we have to keep going. So 12 doesn't work. 13, 14, 15, 16, none of these are working so far. 17, 18, 19, 20, 20 works. 25 also works. 25 goes into 1,000 40 times. So from here, it starts to repeat because this makes a pair. And 40 is the next divisor on our list. So then 20 and 50, 10 and 100, 8 and 125, 5 and 200, 4 and 250, 2 and 500, and 1 and 1,000. So total we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 total divisors. So this was pretty easy because 1,000 is a fairly simple number to find its factors, and it's also not that large. However, if I gave you a number like 10768, that would be quite difficult to do, and we certainly don't want to sit here and list out all the numbers. So we're going to go over the trick for finding the number of divisors. So the first part of doing so is I'm going to start writing off what we need to do off to the side. But this will be our go-to list of what the steps are. So the first step is prime factorization. Okay. So we're going to take, let's go with 144. 144. So prime factorization, if you're not familiar with it, I'm going to explain it here. But basically, you start off with what we like to call a little factor tree. So you pick two numbers that multiply to give you 144. And I know that 12 and 12 multiply to give me 144. So because we have 12 and 12, from here, if the number that you picked is not already a prime, you're going to continue down the tree. In other words, 12 is not a prime, so we have to find two factors that multiply to give us 12. So we know 3 and 4. Now let's take a look. 3 is in fact a prime, so we're going to go ahead and circle it. Then 4, we have 2 and 2, and those are prime, so we're done here. Same thing over here, we have 3, 4, 2, 2. All of these get circled. So then what you're going to do is you're going to list it in exponential form. So and that means when we have 4 2s, we actually have 2 to the 4th, and 2 3s, so we have 3 squared. The next step is you're going to add 1 to all exponents. Okay. Why are we adding 1 to all the exponents? That is a really good question, and it's very frequent that we get this question. But basically, the reason for that is, I'm just going to list out this, and you'll notice as soon as I explain it to you. But any factor of 144 can be made with a combination of any of these. Any of them whatsoever can be made using these combinations. So let's pick one of the factors of 144. 12. 12 can be rewritten as 2 squared and 3 to the first, right? And we have maybe 24. That can be written as 2 to the third and 3 to the first, so on and so forth. Or even 1. 1 can be written as 2 to the 0 and 3 to the 0. Now, if you're familiar with taking combinations, with combinations, you always multiply the number of choices that you have with each other. So here we have 5 choices, and here we have 3 choices. So the total number of combinations we can make is 15. And remember, each combination creates one of the factors for 144. So that means we have 15 combinations, so 15 factors. So that actually leads us to our last step, which is multiply numbers from step 3 together. Does that make sense? So if you don't really understand the reasoning I explained right here, don't worry, because Mathcounts or any math competition will never ask you to test, or will never test your proofs or your understanding or reasoning behind approaching a problem a certain way. So these are just the steps that you should memorize. 1, prime factor. 2, exponential form. 3, add 1 to all exponents. 4, multiply the numbers together from step 3. So now we're going to practice using another example. And let's go back to our original example of 1,000. So remember, the first step is to prime factors. So we have maybe 10 and 100. Then we get 2, 5. Those are both prime factors. Then 100 is 10, 10. Then we get 2, 5, again prime factors, and then 2, 5, again prime factors. So we get 2 to the third times 5 to the third. So this is our exponential form. So this was prime factoring. This was exponential form. Now we need to add 1 to both of the exponents. So 3 plus 1 gives us 4, and 3 plus 1 gives us 4. So this is adding 1 to the exponents, right? The next step is to multiply. So 4 times 4 is going to give us 16. And remember in the previous slide when we did it, we did in fact get 16 factors for 1,000. And look at how much simpler this is. The reason why this method is efficient and accurate is because, one, all you have to learn really how to do is just memorize these steps, but the really basic skill that you need is just to know how to prime factor. And the second reason why it's accurate is because you never have the chance of messing up on what factors there are. And the reason why this is so helpful is oftentimes problems will not ask you whether or not this number is a factor or for you to list out all the factors. Instead, all it will ask you is how many factors there are. So they are really looking to see whether or not you know this, because if you do know this method, then the problem doesn't take very long. All right, so then now there are some caveats to it. So there's the number of even divisors, and the number of odd divisors. So everything is pretty much the same thing about having to factor. So you have prime factorization, exponential form. And then step 3 is where it gets a little bit different. You must remove one of the 2's in even divisors. 4 is add 1 to the exponents again. And 5 is multiply. And instead of explaining why you need to remember 1, 2, I think it's just better to, maybe in a later video I will explain why, but because you don't need to know the proof for any math counts problems, I'm just going to leave it as it is. And so the number of odd divisors is similar, so it's prime factor, exponential form. Number 3 is different, and except this time you have to remove all 2's. 4 is add 1 to exponents, and 5 is to multiply. So we'll go over 2 examples, or one of each. So for even divisors, we have 100. When we factor that, we get 10, 10, 2, 5, 2, 5, and then we get 2 squared times 5 squared. So then here, when we want to find the number of even divisors, we're going to get rid of one of the 2's. So this 2 becomes 2 to the first instead of 2 squared. Now let's add 1 to all the exponents. So 1 plus 1 is 2, 2 plus 1 is 3. Multiply them together, you get 6. Does that make sense? Okay. So next, let's look at odd divisors. So we have 100 again. We already know the prime factorization and the exponential form, so I'm just going to go ahead and write it, 2 squared and 5 squared. This time you get rid of all the 2's because even having one of the 2's multiply into your combinations will make the number even. So we're going to get rid of all the 2's. Now, you might think we have 5 squared. Okay, so we add 1 to the exponent, so we get 3. But what do we multiply together? Nothing. If all you have is 3, then the answer becomes 3. Okay, so that's it for this video. The basis of finding the number of divisors really depends on knowing your divisibility rules, knowing how to prime factor, and just remembering the key differences in a few of the steps. So remember the special middle steps for the number of even divisors and the number of odd divisors. And with practice, this will become a whole lot easier. Hey guys, it's Meghana from Math with Meghana, and I hope you liked that video. If you did, make sure to like, share it with a few friends, and don't forget to subscribe. And please leave any comments with suggestions for video ideas or any suggestions to make my videos better. And I'll see you guys next time. Bye!